5 for 5, and we'll go ahead and get popping here. I know I ain't been on for a minute, so I'm kind of out of practice, guys. Yeah. I don't look for a whole lot of people to be here either. I appreciate you guys that are here. 5 for 5. Cool. Thanks, Tom. Appreciate you, bud. I seen you in there, Hilly. Good to see you, man. I ain't seen you in a minute. Tater tots. That's what I'm saying. Oh, Candace, what's up? Try to say hi to everybody real quick. I'm sorry. Heather, what's happening? Yeah, guys. So I'm going to go ahead and jump into it. You know, I've been trying to put some edited videos out. I've just been having some things going on, but what I've come to find out, and I knew this already, but I haven't been in a place where I could go to my computer and just do what I'm doing right now. I was trying to do it on my phone, and when I do it on my phone, I have to, like, you know, obviously I'm not going to go live on it. I could, but I'm not. You know, just got a lot of things going on right now, and I do, you know, like I said, guys, I do apologize for that. I've been trying to keep everybody up to date on things that are going on. When big things happen, I was posting, just letting you guys know. Yeah, DB, no, we're not all gonna die. That's something that you know. And thanks for deleting that, Hilly. I do appreciate that, guy. Yeah, we don't want that kind of a thing. We don't do that here. We don't fearmonger. If it was a joke, all good. But yeah, Hilly did the right thing there. Thank you, Hilly. But listen, we don't do fear here at all, period. We don't fearmonger. We just try to say what it is, and we just move on, right? I trust my mods and what they say and what they do, and so we're just going to kind of move on from there. But yeah, and again, guys, I really don't think there's going to be a whole lot of people here. For one, it's about 4 o'clock in the morning where I'm at, and I haven't live streamed in, gosh, who knows? You're only scared of Karen. But I appreciate you. I really do, Tater Tots. I appreciate everybody that sticks with me and all that. I really do. Yeah, there's a lot of things going on in my life that I have not talked about at all, period, to anybody. And, you know, I'm just going to leave that at that. It's not, yeah. I mean, it has nothing to do with anything on the internet whatsoever. It's, I got some stuff happening, and, you know, guys, I'll just put it to you this way. You know, value the time you have, okay? You know, you don't get it back. You don't, yeah, you can't go for it anymore. I mean, you got to forget the money, forget any kind of material, anything, and just value the time. And that's really what should be important. And, you know, I ain't saying we shouldn't do things in our lives and stuff like that, but just know that the time is the most valuable thing. And you can't get it back, and you can't buy more of it. So, you know, so enough of that. We'll get into the space weather, and yeah, I'm going to put the chat away. I do trust my moderators. So, hey, Blue, what's up? Hilly, thanks for being here, and everybody else. American, what's up, bud? Or sister. I'm not sure if you're a man or a woman. I apologize. But, okay, so we are going to go ahead and just jump into this. We did, guys, we had like an M2.61, I think, flare. It's right here. Obviously, you can see that with the X-ray production. And yesterday, guys, we went into a geomagnetic storm. It popped right here, and then we popped down out of G1 levels, and then we went back into it for about 6 more hours. That's significant. It's not, you know, what was kind of crazy about that. Hey, thanks, Jerry. I appreciate you. Yeah, we got a 1-2 punch. Exactly. Well said. That's kind of what that was. And what happened was there was one of the CIRs, and we've talked about that, what a CIR is. I'm not going to get into what that is right now. But there was an embedded CME in that CIR. So, and it was a stealth CME. And I seen it when it happened, and I think I even talked about it. I think it was in one of my videos. I didn't go look. But I mentioned to you guys, you could see like a really faint halo. And we'll look at that here in just a minute. But it ended up being a stealth CME. And those are really, really hard to detect. And I'm going to show you some things here, too, to kind of try to help you guys see those things a little bit easier. As we get moving on into the solar cycle, those are going to become harder and harder to find. And the reason why is because the sun's, it's erupting all over the place. So you got a camera looking at the whole sun, right? So if it's erupting in multiple places, it's kind of hard to see the smaller ones because the bigger ones are kind of, taking all the attention. So anyway, we'll leave that part of it right there. But so this geomagnetic storm here, and I'll show you when it. Let's see if I can do that. This is today, okay. If you guys see what I'm talking about right here. I mean, it's erupting in all different directions. So it's not just one side of the sun. I mean, the whole sun is active right now. And, we kind of went through about a month or two right there that was kind of slow. But we're picking back up now. The sun's waking back up, and we're seeing that. That last eruption over here on this left side, this is from SDO. It's from our point of view. That last one did come from that M flare. Now, is that M flare coming at us? Not really sure. Hey, Whitetail, what's up? I'm not really sure yet. It has a chance of coming our direction. So I went over here to Stereo A, which is and I'm going to explain something here too, guys. Stereo A used to be really at 90 degrees. And here, I'll tell you what. Let's do this. You guys see this up here? Okay, this is the Earth. I'm just going to use this little crude graphic right here. And I did this in one of my other videos. But the Earth's here, and I just showed you Soho, and it's about 1 million miles closer to the sun than what we are. Okay, it's right out in front of us. It's right here. It's always looking at the sun. Well, Stereo A, and it depends on if you're looking down on the sun or up at the sun. That's why this says Stereo B on the left side, and this says Stereo A. And most of the other graphics that we look at is kind of flip-flopped, right? It's not, okay? It just depends on if you're looking down or up. And I know it confuses a lot of people, but Stereo A, for when we look at it like on these models here, the stereo is looking right at the sun, but it's off to our left, okay? It would be to our left in our orbit. All right, and I know that's kind of hard when you see a graphic like this and it's saying the opposite. But anyway, Stereo A used to be way over here about 90 degrees. We had a really good, side view of the sun, and it was really even gave us a pretty decent look at the backside. Now, by design, it's about right here. Okay, and I tell you what we could do. Hold on one second. Pull this up here. Okay, this is the CME tracker. This is NASA's version of it. This is Stereo A. You see this right here? This satellite used to be over here. So you see how that perspective gets changed? So now we have really basically a very slight angled view of the sun now. And that matters when we're trying to look at the direction that these things are coming off the sun. If this thing was over here, if the satellite was still way out here, this right here, I'll show you. This eruption, it looks like it's going way off to the left, would not look like that. It would almost be coming right at Stereo A. You got to kind of move your mind over a little bit, okay? But because that satellite has changed position, it changes what we have to look at and what we have to take in consideration. So when this is showing it's going off to the left here, it's probably coming more at an angle. So this still has potential of hitting us, is what I'm saying. So, and again, we're not going to be able to tell until we get more data in. It's still pretty early. And you can see it erupting off there. And it is. It's a sizable one. It came from an M flare. Typically, CMEs that come off of M flares are pretty decent as far as their strength and stuff like that. I'm not talking grid down stuff. When we're talking grid down stuff, we're talking X flare plus, right? But yeah. So I'll tell you what we'll do. We'll go back over here and we'll check this out again here. This is Soho right out in front of Earth. This is from our perspective. So you can see from our perspective, this bigger eruption that pops right about there. See how it looks like it's going to the left? And so did the other one. Now, if that satellite was still way over there, 90 degrees, that would really kind of point to that thing going more towards the backside. But we can't say that now because it's now, instead of, if you can kind of pretend that, we're looking right at it and stereo A used to sit over here, it's kind of over here now, if that makes any sense at all. And without having a three-dimensional model to show you guys, it is hard to show that. But and these eruptions are going to continue to happen. We did have, we had a radio blackout when that flare hit. And that happens often, okay? This isn't nothing out of the ordinary. We're going to see this all the time. I mean, we have been seeing this all the time. So I'm not even sure if we're probably even past the time. Yeah, we are. That's where it hit. It was over the Pacific when it hit. And so it didn't really probably affect much of anybody except for maybe mariners, people out there on the on the boats and stuff. It didn't happen over a big, large land mass or anything. Which actually, believe it or not, guys, that happens more times than not. Because you got to keep in consideration our planet is, 70% water? So, it's got a better chance of being over top of water than it does being over top of land. Anyway. So, yeah, and what did this do? Well, it gave us some pretty good aurora. I can't show you that right now because this doesn't go back that far. But what we will do, I want to talk about the what I had on the thumbnail there because I don't want to, not talk about what I put in the titles. But here's that flare, okay? And what we'll do is we'll be able to see it better here. I'm going to pause it. And it's a decent sized flare, okay? Let's see if I can catch it. There it is. See that? It's a pretty photogenic flare, to be honest with you. You can see how the magnetic connection lines and how it was interacting with a lot of these Archie number things. And it really, pretty cool looking, actually. And it was pretty long lasting. It was a fairly decently long flare. Picked it up about right there. That's at 2025. Wow. I didn't even realize it went that long. Wow. We're talking a couple hours at least. Looks to be anyway. Let's see here. Yeah, we're talking 5-6 hours. Just that. Erupting. You see it over here on the 131 also. Well, and again, these are just filters for the cameras. See that? Right there. So yeah. That happened. We'll just leave it at that. Now, I'm not going to show you these two because they really don't show a whole lot. So what we're going to do here real quick, and I want to show you guys because, we talk about storms, so, stealth CMEs. What's a stealth CME? Well, it's essentially a CME that's really hard to detect, okay? So what we're doing here, and as you look at this, you can see that, right? That's a coronal hole, and this is back on the 3rd. So what I'm going to do is I'm going to play this, and I've got this sped up so you can see what this thing actually does. And I was checking out Tamantha Scove's channel, and she did a video on this. You guys should go check it out. And she called it "The Sun Was Winking," and you'll see what that means here in just a second. See that? See what that coronal hole does? See how fast that closes up? It's not unusual for that coronal hole to close up like that, but what we have to understand is there are magnetic filament channels through here, and if you look really, really close, and I'm not going to slow it down because I just don't have the definition to really show it to you guys very well. Well, I can slow this down so you guys can see that better. But when that erupts off there, you can see a little bit of around the edges here, a little bit of an eruption. Not this one that came from over here, but around the edges of the coronal hole when it happened. That was the stealth CME. Basically, it was like a filament releasing off around that coronal hole. And you could barely see it in the graphics. And again, she did a really, I like that analogy, winking here, because It's a really good way to show that to you guys. And so, again, this was a sizable coronal hole. Those filament channels they released off caused a CME, a stealth CME that was just kind of got embedded into the solar wind. Because you got to think, most of the solar wind's coming right out of this hole right here. So if you get a CME right around the edges of it, it's going to be hard to see it. It's going to just get incorporated. Because a stealth CME typically is not that strong. Okay? And this one wasn't that strong either. It's just the combination. And what it did was it added density to the solar wind. Up to like 50. 4 is normal. Okay? 50 is substantial. So when you get that density up that high and it hits, it's going to do something, typically. And what it did was, obviously, our magnetic field reacted. And, you know, we had a geomagnetic storm. It caused some cracks in our magnetic field, and it let stuff in. And that's why we ended up with geomagnetic storm. Now, it was low level, right? It's not wasn't a big eruption. It was just something that most people didn't see. And NOAA, I even showed this on my last video, NOAA had predicted a possible G2 out of that. I showed that to you guys. I didn't voice over that video. It was all text and stuff. But I even zoomed into where it said G2. So NOAA expected this thing to be there. So it wasn't like this was not predicted. Because it was. This was predicted. So somebody's seen that. Is what I'm trying to say. And it wasn't just those of us out here that look at this all the time. Somebody actually like, hey, that's a stealth CME. We may end up with some geomagnetic storm levels. And they reported it, and it came to fruition. It actually happened. So that's a good thing, because we're going to see a lot of stealth CMEs get embedded into these bigger eruptions because we're going to get more active. So some of these stealth CMEs, we're going to get geomagnetic storms that we didn't see coming. It's just going to happen. So the better we get at looking at these stealth CMEs, the better off we're all going to be. Okay, that's kind of what I'm saying. And not that it's going to cause any big issues. It's nice to know that kind of stuff. Because if you get like a stealth CME hit that you didn't see coming, it puts you into like a G1, maybe a G2 level storm. And then maybe there was a big flare of CME behind it that happened that everybody's seen, but nobody's seen the one in the front. So now we get a double hit, and that second one hits, and bam, then you got issues. That's why it's important to know how to look at this stuff. And there's a whole lot of other reasons too. But you can see, guys, and even when this thing erupted off, watch how active it gets around the hole. And that is a pretty big coronal hole. We definitely did get uptick from that. Again, that and that stealth CME is what put us in the storm level. So I just thought that was, I thought you guys should be able to see that and understand what I was saying there. Hopefully I articulated that well enough you guys can understand. But yeah, you should go check out Tamitha Scove's video on this, because she does a lot better job of explaining what I just said. So yeah, go check it out. Okay. SpaceWeather.com. Again, guys, give these guys some love. Go check them out. I'm not going to stay here looking at this because I want you guys to go look at it for yourself and give them some traffic. That's it. These guys are in my description box. It's Dr. Phillips. He's the one that does this channel here. But you can see long duration solar flare. That's the one I just showed you guys. I mean, this thing, I showed you guys how long it took, it stayed there. But check this out. I did not even know this happened. Right? I'm not afraid to say that. You're going to get people out here that's going to report on this, and they're going to act like they knew this. It kills me what people do. I did not know this. It's the first accidental geomagnetic storm. Yeah, accidental geomagnetic storm. How is that possible, right? Well, guys, it was a nuclear bomb test back in 1962. And this even surprised the scientists back then. It caused one of the biggest geomagnetic storms of the space age. And it was that this thing detonated at 250 miles above the ocean over the Pacific. So, yeah, just kind of understand all that. That's and please go over here and read this, because they were seeing aurora, red aurora, it looks like, in Hawaii. And when we start seeing these different colors of aurora and stuff, those are different kinds of molecules. And if you understand how aurora works, what happens is the solar wind comes in and it excites the molecules that are there, like oxygen, nitrogen. And the color that you see is when those molecules are actually going back, trying to get back to their stable state. So as they're going back to that stable state, they put off that color. And that's just that's a basic explanation there. There's a whole lot more going on there, but that's how that works. Just very basic explanation. And you guys can Google that, how aurora is made, and all that. So again, you have to have some sort of opening for that to get into our atmosphere in order for the solar wind to, in order for the space weather to interact with the molecules. So it's either got to have a crack in the magnetic field, or it's just got to come in on our poles or wherever it's coming in at in a natural way. But typically when you get the big blast from the CMEs and stuff, they're coming in on the north and south poles, but it also will create cracks. And that's when you start seeing it down towards the equator. And the bigger CMEs, you're going to see them at the equator. Now, I don't know what they did after all this. And again, guys, I don't want to read the article because they did the work here, okay? I just wanted to show you where this is at. As a matter of fact, I'm going to put this link in the chat. I don't like, I just don't like, they did the work. They should get the traffic. That's all I'm saying. They get the credit for that. So it's really well written. And you can go down through here too. And something else I didn't get a chance to talk about, guys, is this. These are Noctilucent clouds. These clouds, I've talked about this before. I haven't talked about it in a minute because I haven't been here. But these are blue metallic looking clouds. They're caused from water vapor freezing around meteor dust in the highest parts of our atmosphere. And they happen in the summertime of each equator, or each pole, sorry. So when you see these things, that's what they are. And they look very blue metallic looking, and they're way up there. And people have asked me, why is it in the summertime? Well, because you get more water vapor, because you're getting a lot more glacier melt and stuff like that from the heat. So it takes that water vapor, and when you get so high up in the atmosphere, things freeze anyway. So that's why. Yeah, they are. Noctilucent clouds are very beautiful, 100%. But yeah. So that's really all I got for you guys. I don't have a whole lot more here. I don't want to make this too much longer. And again, guys, I'm not going to promise being on here live streaming too awful much. I just, yeah. So just like I said earlier, guys, just value your time. That's all you got, and make the most out of it as you can, and just keep moving, keep rolling with it. Love each other. That's all you can do, right? So, yeah. But anyway, guys, yeah, those are pretty interesting, aren't they, Candace? And, hey, you're welcome. What's Heaven's calling? Yeah, hey. Hey, Greta, what's up? And I appreciate you guys. I really do when you guys leave comments and stuff. I do. I try to read most of them. Sometimes I miss them. Sometimes I just don't have the time or just simply miss them. I don't see it. But I do appreciate you guys. And like I said, I do. If something big does happen, I promise you I'll come on and at least drop a 2-second video to let you guys know, hey, this is happening, and then I'll move on. So back at you, Buck. Back at you. I love that. I love that little hand wave. That's right. Back at you, Trista. All right, guys. I think I am going to go ahead and we're going to go ahead and cut her off here. Again, guys, doing this live stream, it's probably faster for me to do this than it is to do what I was doing before. So if I'm able to be home and be in front of my computer, I'll probably do it this way most of the time. But and I may even just do some voiceover edited videos because trying to type all that stuff in takes quite a bit of time. I just haven't been in a place where I can actually do that, and it's hard to do it on your phone. So, but anyway, guys, we're gonna go ahead and cut off out of here, and yeah. So, God bless. Yahusha saves, and like always, you can drink this Kool-Aid.